Hello everyone. In this lecture, I'm going to explain encoder and different types of encoder design as well as priority encoder. Okay, so first, what do you mean by encoder? So encoder is a combinational circuit which is made up of basic logical gates, and encoder is an important tool in the communications. So we are going to use this encoder in the transmission part of the communication side, and which is similar to multiplexer, but in multiplexer we are using extra control signal, but in encoder we are not going to use the extra control signal, and it is going to be designed by the principles of 2 power n is to n. So 2 power n is the input and n is the output. That is, the simple example is 4 is to 2 encoder. That is 4 inputs and 2 outputs. That is 4, this is a 2 power n, so n is equal to 2, so it is 4 is to 2. So in the transmitter side, we are going to use this encoder. That is, we are going to combine all the data and we are going to send it as two data to the receiver side. At the receiver side, the decoder will be there. So decoder is going to receive the data and it is going to extract it. This same to the multiplexer and demultiplexer operation only, but in multiplexer and demultiplexer we have used selection lines, but here we are not going to use selection line. Okay, right. So in the introduction part, it is in a combinational circuit, performs the reverse operation of decoder. Yes, decoder we will discuss in the later part. So it has maximum 2 power n input lines and 10 output lines. So input is 2 power n and output is n. Okay. So it will produce a binary code equivalent to the input, which is active high. So whenever this input is a active high, see, 4 is to 2 means any one of the inputs should be active for each combinations. That is 0, 0, 1, 0, 0, 1, 0, 0, 1, 0, 0, 1, 0, 0, 0. So at a time only one input should be high level. Okay, so this is the lowest priority, so the lowest output 0, 0 will come here, then 0, 1, 1, 0, 1, 1 will come. So therefore the encoder encodes 2 power n inputs line with the n bits. Yes. It is optional to represent the enable signal in decoders. Yes, the enable signal is most probably in the larger circuits, everyone is using enable signal. So for the low level circuits, no need of use enable signal. So there are 3 types we are going to discuss here: 4 to 2 encoder as well as 8 to 3 encoder and priority encoder. So while using this 4 to 2 encoder and 8 to 3 encoder, some disadvantages will come. So to overcome those disadvantages only, we are going to use this priority encoder. Okay, so this 8 cross 3 encoder, which is otherwise called as octal to binary encoder, because the reason is, so 8 means it is in an octal, because we know that the octal number ranges are from 0 to 7. So here we are going to use the 8 inputs, so that's why it is called as octal. And 3, so in octal, in binary format, how we are going to write? It is in a 3-bit representation format. So that's why this 8 is to 3 encoder is otherwise called as octal to binary encoder. Okay, we'll move to the topic. So first of 4 to 2 encoder, so 4 inputs and 2 outputs. So I'm going to consider those inputs are Y3, Y2, Y1 and Y0, and 2 outputs are A1 and A0. Okay, let's have a look at the block diagram. So 4 inputs, Y3, Y2, Y1, Y0, and 2 outputs A1 and A0. Okay, right. So at any time, only one of these 4 inputs can be 1. Yes, just now I told you, no? So at any time, only one of the inputs, maybe first time this Y0 will be 1, second time this Y1 will be 1, and third time this one, and fourth time this one, as per the priority level. Okay, so let's have a look at the truth table. So first combinations, Y0, the lowest level is 1, so the lowest output 0, 0. The next highest level, next highest output 0, 1. Next highest level, the next 1, 0 output, and the next highest level, and 1, 1 is the output. Okay, right. With this, we can derive the expressions for A1 and A0. So A1, have a look at this, in 2 places it is 1, that is when Y2 is 1 as well as Y3 is 1, this A1 is 1. So I'm going to write the expression as A1 is equal to Y2 plus Y3, because for these 2 conditions only, output A1 is equal to 1. In the other case, A0, which is 1 for which conditions? When y1 is equal to 1 as well as y3 is equal to 1. So we can write the expression for A0 like this. So have a look at this. So Boolean functions, A1 is equal to y2 and y3 and A0 is equal to y1 and y3. So only one OR gate is needed to represent this A1. Similarly, here A0 also only one OR gate is enough to represent. Okay. So have a look at the circuit diagram. Okay, so two OR gates are taken. So A1 expression is y3, y2. So y3, y2 is given to the A1. Similarly for A0, y3 and y1. So y3, the line is coming from this point to here as well as y1. Okay, so this is the design of 4x2 encoder. Next, octal to binary encoder. As already I said, octal 8 and binary 3. So 8 input and 3 output. So have a look at this. Y0 to Y7, 8 input and 3 outputs are A2, A1 and A0. Okay, right. So now let's do table creation. So Y0 to Y7. So each time only one input is going to be 1. So first time lowest Y0, second time Y1, third Y2, then Y3, Y4, Y5, Y6 and Y7. Okay, so 8 different combinations of inputs are there. So 8 possible output is also there. So for the lowest combination, I am going to give the lowest outputs are 000 and 001. The next combination 010, 011, 100, 101, 110, 111. So these are all the proper ascending order of decimal number. That is, this is 0, this is 1, 2, 3, 4, 5, 6, 7. So that's why these outputs are given in the proper ascending order of all the combinations of input. So now I can write the expression for this A2. How to write the expression? See, for these 4 conditions, this is equal to 1. So what is this condition? Input is, it is Y4, right? So here I am going to write Y4 and this is Y5, this is Y6 and this is Y7. It is Y4 plus Y5 plus Y6 plus Y7. And similarly here, A1 is here 2 ones, here 2 ones. So the combination is, this one is Y2 and this one is Y3. That is, have a look at this, Y2, how I have written Y2? This is Y2 and for this condition it is Y3. Similarly for these 2 conditions, Y6, Y7. So I am going to write the expression is A1 is equal to Y2 plus Y3 plus Y6 plus Y7. Similarly for A0, this is Y1, this is Y3, Y5, Y7. So Y1 plus Y3 plus Y5 plus Y7. Okay, right. So the next is Boolean function. This is a Boolean function. Just now we have derived from the table, and only one OR gate is enough to draw this, and here only one OR gate, and here also only one OR gate is enough. Have a look at the circuit diagram, that is logical diagram. Here 4, 5, 6, 7 are input for A2. So this is A2. Have a look at this. 4, 5, 6, 7 is given as the input for this first OR gate. And for A1, it is Y7, Y6, Y3, Y2. So already Y7 and Y6 are taken from here. Okay. Then Y3, Y2. There is a Y3, Y2. And finally A0, it is a Y1, Y3, Y5, Y7. So Y1 is here and Y3 is here, Y5 is here, as well as Y7 is here. Okay, so this is the design of octal to binary encoder. Okay, so now in this encoder there will be some drawbacks will be there. That is, see, just take this example. Y3 and Y6, if both are simultaneously 1, 1. So as per the encoder conditions, any one of the inputs goes high, the output will come. If suppose simultaneously 2 inputs are 1, 1 means, so which output will goes? Whether this Y3 output will goes or Y6 output will goes. Because Y3 output, we are having the previous, see what is the Y3 output? Y3 output is here, when it is 1, this is a 0, 1, 1, right? When it is 1, this is 0, 1, 1. When Y6 is 1, this is 1, 1, 0, 0. So now for this condition, which output will goes? Whether 0 1 1 will comes or 1 1 0 will comes. So this is the main drawback in encoder. Okay. So to overcome this problem only, next we are going for a priority encoder. If in priority encoder, if y3 is 1 and y6 is 1 means which is having the highest priority, y6 is having the highest priority, then that particular output will goes to the output. This is the concept of priority encoder. Okay, so to overcome this problem only, we are moving for priority encoder. Okay, right. So now we'll go for the design of priority encoder. So first I'm going to design a 4 to 2 priority encoder. So 4 to 2, 4 inputs and 2 outputs. So those inputs are y3, y2, y1, y0, and 2 outputs are a1 and a0. Okay. So see here this is y0 is the lowest priority, y1 next highest priority, and y3 is the final highest priority. Okay. So when y3 is high, remaining all other bits are whatever it may be. Maybe it is in a 0 or 1. Okay, so the output is, it will goes 1 1. Okay, the next higher priority y2, then this continuation the output goes to the next highest output 1 0, and here is 0 1, and here is 0 0. We'll have a look at the truth table, you can easily understand. And here I'm going to use one V, that is V for valid outputs. Okay, that is output is valid or not. In a previous encoder, if suppose all inputs are, that is I have used of y3, y2, y1, y0. If all inputs are 0 means what will be the output? This is not possible in encoder, right? Any one of the inputs should be 1. So if all the 4 inputs are 0 means the output will come as 0. So to indicate this 0 or 1, we are going to use one valid input, valid output V. Okay. If any one of the input is 1 or only, this V value is equal to 1. If all 4 inputs are 0, then this V value is equal to 0. Let's have a look at the truth table, you can easily understand. Okay. Right. Have a look at this truth table. That is y3, y2, y1, y0. In the proper order I have written. Then a1, a0, then V. So have a look at this. The first condition 0, 0, 0, 0. All are 4 zeros. So the circuit is invalid. Okay, so encoder means it should satisfy the condition as any one of the inputs should goes as 1. So now this condition V is equal to 0, and the inputs outputs are 0 0 1. Okay, next the first priority goes to the lowest input y1 is equal to 1, remaining all are equal to 0. So for this condition the lowest output is 0 0 and V is 1, because one of the input is 1, so V should be 1. The next highest priority is goes to y1. At this time, this y0 is x. So this is whatever it may be. Maybe it is 0 or 1. So for this condition, the output is the next highest output 0 1 and V is 1. And the next highest priority goes to y2. For this condition, y1 is don't care and y0 is don't care. That is, we can use 0 1 here and we can use 0 1 here. Okay, that is one time you can consider 0 this one, and another time you can consider 1. Okay, so we can write multiple combinations for this don't care combinations. So now the next highest priority output is 1 0. So V is 1. The next final highest priority goes to y3. When y3 is 1, these 3 are don't care. So this don't care is very very important. That is, see, let us take a second combination 0 0 1 don't care. So for these combinations I can write out two conditions. That is, first one is 0 0 1 0. The second condition is 0 0 1 1. That is, in the place of x, I can write 0, 1. So for 0, 1, don't care, how many conditions I can write? So in the place of xx, I can write 0, 1, sorry, 0, 0, 0, 1, 1, 0, 1, 1. So 4 conditions I can write. So this is 0, 1, 0, 1, 0, 1, 0, 1. Similarly, 1 triple x. So here I can write 8 possible combinations that starts from 0, 0 to 1, 1. Okay. So have a look at this. The next step is we need to find the expressions for a1, a0. So now I have explained, no, in the place of x we are going to write some combination 0, 1, 0, 0. So let us take a 0, 0, 1 don't care. So 0, 0, 1 don't care. That is, one time I'm going to substitute 0, another time 1. So 0, 0, 00100011. So